Welcome to everyone. In this video, we're going to see the ninth standard quadrilateral units, one of the theorem. Its name is midpoint theorem. Before entering to theorem, let us see what is the statement of a theorem. So in this statement, it states that if you consider a triangle and if you form a line segment by joining any two midpoints of the sides, or else you can say that if a line segment is formed by joining the midpoints of any two sides of a triangle. Suppose if I have taken a two midpoints of this way, and when this line segment has been joined, suppose if you give a name of a triangle A B C and this is D and E, what it states that here DE is parallel to BC. It means the newly formed line segment will be parallel to the third side, and DE is also half of BC. This is what he gives a statement in this theorem. Repeating once again that here if you form a line segment by joining any two midpoints of a sides of a triangle, then that line will be parallel to the base and it will be half of the third side. So basically, on which principle we are going to prove this theorem? In this theorem, we are going to do things using two things. That is, one is congruency, and other thing is how can a quadrilateral become a parallelogram? Under what condition? Here, the condition what we are using is if we prove that a pair of opposite sides are equal and parallel. Suppose if it is a quadrilateral ABCD. If I prove that AD is parallel to BC and AD is equal to BC, then I can say that given this quadrilateral ABCD is a parallelogram. So these are the two principles on which the theorem is going to be proved. Now let us go to the theorem. So here we are going to see the statement of a midpoint theorem, that is the line segment joining the midpoints of any two sides of a triangle, then it is parallel to the third side and half of the third side, what we have already discussed. That is, if a line is drawn by joining the midpoints of any two sides of a triangle, this newly formed line segment will be parallel to the base and half of the base. So after having the statement, there will be a diagram. So this is a diagram in which let us see what we have considered. It means data. So given what he has given here, triangle ABC we have considered, in which D and E are the midpoints of AB. So here we have considered triangle ABC where D and E are the midpoints. D and E are the midpoints of the sides of a triangle, and of where AB and AC and D is been joined. This line segment has been joined. So after considering this, let us see what he has we have to prove. To prove here, we have to prove that is this line segment which is formed is parallel to the base, and D is also half of the base, that is BC. It means third side. After having that to prove, then we are having construction. Here in construction, what we have did, draw CF parallel to BA. Here CF has been drawn parallel to AB. This line has been drawn such that it be a parallel to what? AB. Then meeting D produced in F. When D is being produced, it has met at a point where F. This is about the construction. Here CF has been drawn parallel to AB, and which is next D has been extended to meet at F. Next is proof. It comes statement and reason, and first we have consider two triangles. As I have told you that in a previous part that Two principles we are going to prove the statement, and one is congruency and other is quadrilateral is a parallelogram. Here which triangles I have considered? Triangle AED, where it is AED, this triangle, and one more triangle. What is that triangle? CEF, where it is CEF. Here we are going to prove these two triangles are congruent. Let us see the next step. That is AE is equal to C. Where is AE? AE is equal to C. Why? Because we have considered that E is a midpoint. If E is a midpoint, then the AE must be equal to C because of already he has given. So that is the reason given. And let us see the next thing. That is angle AED, where it is angle AED is here, and CEF it is here. They both are equal because of vertically opposite angles. The next step is DAE is equal to FCE, where it is DAE. DAE means this angle is equal to FCE, this angle, and already we have shown that this is equal to this because of vertically opposite angles, and AE is equal to EC. We have already proved based on ASA criteria. We can say that the given two triangles are congruent. See the next step, that those two triangles becomes congruent based on ASA criteria. Then based on, if we have proved the two triangles are congruent, then I can say that the rest of the remaining parts are equal based on CPCT. It means corresponding part of congruent triangles. Here, since we have proved that this triangle and this triangles are congruent, so based on that I'm going to say that here AD is equal to CF. At the same time, DE is equal to EF. That's what we have written here. That is AD is equal to CF and DE is equal to EF. That is because of CPCT. But see here that we have told that AD is equal to CF because of CPCT. At the same time, we are having a given data that AD is equal to BD. Why? Because AD is equal to BD because we have considered that D is the midpoint of AB. If D is the midpoint of AB, it is sure that AD must be equal to BD. So it is because of given thing. When you consider these two equations, that is AD is equal to CF and AD is equal to BD, according to the axiom 1, things which are equal to the same things are equal to one another. That is, these are the things which are equal to same things. Then this CF is equal to BD because of axiom 1, things which are equal to same things are equal to one another. So here BD is equal to CF, which becomes here BD is equal to CF. At the same time, when we have taken a construction, we have thought that DE is, sorry, that is here in construction, that is CF is parallel to AB. If CF is parallel to AB, then automatically BD is a part of this part, that is BD is a part of AB. Therefore, at the same time, BD is also become parallel to CF. So according to the one thing that we have learned in a theorem, that if in a parallelogram, if you prove that one pair of opposite sides are equal and parallel, then this quadrilateral becomes a parallelogram. Therefore, what we can write that BCFD is a parallelogram. So once we have proved that it is a parallelogram, then we can write that this since we have proved this parallelogram, that is the DBCF is a parallelogram. Therefore, I can write that DF is parallel to BC. That is what the other side, DF is parallel to BC. Since DF is parallel to BC, you know that DE is the part of DF. At the same time, we can write that at the next step, that is DE is this part. DE is parallel to BC. So we have proved the first part of a theorem, that is DE is parallel to BC. The next thing is, since we have proved that DBCF is a parallelogram, at the same time we can write that what that this DF is equal to BC because of properties of parallelogram. So next step, here we have written that DF is equal to BC. So this DF is made up of two parts. One is DE and other is EF. So we can write it as DF is equal to DE plus EF. Here one more thing we have proved here, that DE is equal to EF. So here instead of EF we can write as DE plus DE, that is DE plus D is equal to BC. Here DE plus DE is nothing but 2 times DE, and here when we transfer 2 to the right hand side, you get D is nothing but half of BC. So this is how we have proved the theorem, that is it is also what this is parallel to base, and also at the same time it is half of the base.